Hello students, welcome to mathematics class. Students, this is part 5 of the chapter Introduction to Graphs. In this part 5 we will do revision of application of linear graphs and will once again revisit the exercise questions of 15.3. This video we are going to watch on 4th February 2021. Coming to the application of linear graphs, in everyday life you might have observed that the more you use a facility, the more you have to pay for it. So, for example, for that, more the electricity that you consume, the bill is bound to be high. If less electricity is used, then the bill will be automatically manageable. So, this is an instance where one quantity affects the another quantity that you could observe. Amount of electricity bill depends on the quantity of electricity that you use. Children, here I am going to introduce you two important terminologies. One, independent variable. Two, dependent variable. For example, here quantity of electricity that we use is an independent variable, but the amount of electricity bill is dependent variable. How means how much you use, the quantity of electricity is independent, but the amount that you have to pay is depending upon the quantity of usage. So, amount of electricity bill depends on the quantity of electricity that we use. That's why it is dependent. For example, if you go to a shop to buy notebooks, number of notebooks that you purchase is independent variable, but the amount that we need to pay after purchasing books will be a dependent variable. So, the relation between such variables can be shown through graphs. Here I am going to take examples. For example, quantity and cost graph. The following gives the quantity of petrol and its cost. Number of liters of petrol and the cost of the petrol. 10 liters 500 rupees, 15 liters 750 rupees, 20 liters 1000 rupees, 25 liters 1250. Whereas it is maybe somewhere in the year 2006. Now anyway, the cost of petrol has increased too, and definitely if you drop for present scenario, you will definitely easily correlate after understanding this solution. Here, plotting the graph of this. How to plot the graph of this? Children, here I am very clearly given the points, that is 10, 500 is 1 point for me. Second point 15, 750, and third point 20, 1000, and fourth point is 25, 1250. Children, to plot these graphs, I need to have the decision of scale. So, the first and foremost thing for us, deciding scale. What's supposed to be the scale? So, the scale of ours supposed to be convenient one for the graph what I am going to take. Suppose I am going to take this graph. In this graph, how many columns are there? How many rows are there? That based on that I will take a decision. For example, see children, here I have limited number of columns but unlimited number of rows. Unlimited means that is also limited within the page. Here now 1, 2, 3, 4, 5, 6, 7, 8. 8 columns are there for me, where rows 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 rows are there. So, based on that I am deciding a scale. So here I took a horizontal axis, vertical axis, and later children, here I have suitable scale on both the axes. What would be the suitable scale on both the axes? That only depends on here marking the number of, for example, if I take this as 0, mark the cost of petrol. Here I am taking on by applying king on vertical axis starting from this. So 2 units, or I say here in each unit I have got 5 subunits. That means 10 units is equals to, that's up to us. Here if I consider this as 1 unit, then I am saying 2 units. 2 units on y axis is equals to 100 rupees. On x axis I am considering here, after taking on x axis 1 unit is equals to 5 liters of petrol. So 5, 10, 15, 20, 25 and 30, whereas for 10 liters I have got 500 rupees, and for here I marked for 15 liters 750, that comes here somewhere, and for 20 liters 1000 rupees, here it comes, and for 25 liters 1250, that comes here. Now after marking points I will go for joining lines. So point this 10 comma 500, point 15 comma 750, point 20 comma 1000, point 25 comma 1250. I am naming as A, B, C, D, and I am joining A, B, B, C, C, D. Now this is a linear graph. Okay, so this is how we do the work. Okay, now let us discuss one more example to make it clear. Here we find the graph is a linear graph. Why does this graph pass through the origin? Because if I purchase 0 liters, definitely the amount that I pay for it, or cost of that 0 liters of petrol, is 0 rupees. This graph can help us to estimate few more things. What are that? Suppose we want to find the amount needed to buy 12 liters of petrol. Now if you go for 12 liters of petrol, it lies between 10 and 12. Here I will go up to here and mark this is 12 liters and its cost is 12 comma 600 rupees. That means 12 liters of petrol is 600 rupees. So this linear graph helps me to definitely say how much is the amount for the appropriate, what is that number of liters of petrol that we wanted to buy. Now here locate 12 on the horizontal axis. I did that. Follow the vertical line through 12 till you meet the graph at P. Say from P you take a horizontal line to meet the vertical axis. This meeting point provides the answer, that was the P 12 comma 600. Okay, so this graph of a situation in which two quantities are direct variation. These two quantities are in direct variation, that is number of liters of petrol that we buy is directly proportional to the cost of them. Okay, that was a one direct proportion what we learned in our previous classes, direct and inverse variation. It is correlated. Now, next example is principal and simple interest. A bank gives 10% of simple interest on deposits by senior citizens. To draw a graph to illustrate the relationship between the sum deposited and simple interest earned, find from your graph the annual interest obtained for an investment of rupees 250. Further, the investment one has to make to get annual simple interest as 70 rupees. See, for this children, 10% is the simple interest. If I keep 100 rupees, 10%. If I keep 200 rupees, 20 rupees. If I keep 300 rupees, I will get 30 rupees as a simple interest. So, this table I have to make. A table, sum of deposited and interest on that. For 100 rupees, 10 rupees will be the simple interest. For 200 rupees, 20 rupees will be the simple interest. Annually, I am talking, this is for 1 year. Okay, for 300 rupees, we will get 30 rupees. For 500 rupees, we will get 50 rupees. For 1000 rupees, we will get 100 rupees and so on. Now, we will decide few important facts, the steps to follow while constructing linear graph. I expect everyone should know this. Okay, you can note down if you are unaware. 1. The steps are follows. Find the quantities to be plotted as deposit and versus simple interest. Decide the quantities to be taken on x-axis and what to be taken on y-axis. Very important, scale. Choose the proper scale and plot the points, then join the points. These are the important 5 steps. Deciding what to be taken on x-axis and y-axis, and scale appropriately choosing, plotting points and joining points we normally used to do. Okay. Now, this extra you are doing, finding even what would be the deposit, and for the deposit what would be the simple interest per annum. So, this table if you make, that table will give you the points to be plotted. Now, the points to be plotted will be 100 rupees gives 10 rupees. So, 100 comma 10, 200 comma 20, 300 comma 30, 500 comma 50 and so on. So, this would be the graph. Here I am giving directly graph where on x-axis deposit in rupees is considered and annual simple interest is taken on y-axis. So, 100 comma 10, here on x-axis I am taking 2 units as 100 rupees, on y-axis 2 units as 10 rupees. The scale, appropriate scale is to be chosen and points I have plotted 100 comma 10, 200 comma 20, 300 comma 30 and it is a linear graph after joining them. Children, here the question can be answered. The annual interest obtained for an investment of rupees 250. 250 lies between 200 and 300. So, 250 I have taken. I have drawn a line from 250 intersecting that linear graph. From there, if I drop a perpendicular to y-axis, it gives me 25 rupees. That 25 rupees is simple interest that I am going to receive on the deposit of 250 rupees. Second question we can answer, the investment one has to make to get an annual simple interest of 70 rupees. If I want 70 rupees as simple interest, from there I am dropping a line parallel to horizontal axis and intersecting the graph. From there if I drop a perpendicular to the horizontal axis, vertical axis, it intersects at 700. So, I suppose to deposit rupees 700 to receive 70 rupees as simple interest. So, deposit supposed to be 700 rupees. This is how we do the linear graph. I hope you have understood. I will give one more example, last example, important graph, that is time distance graph. In physics, this time distance graph plays a vital role in identifying speed of a vehicle, acceleration of a vehicle, and further to learn laws of motion. You have seen those you are going to learn in class 9th. Okay. Now here coming to this question, Ajit can ride a scooter constantly at a speed of 30 km per hour. That means in 1 hour he rides 30 kilometers, in 2 hours 60, in 3 hours 90, in 4 hours 120 kilometers. This is how we at an average speed. It's a since average speed. So you need to draw a time distance graph for this situation. Use it to find what are the questions. The time taken by Ajit to ride 75 kilometers and the distance covered by Ajit in 3.5 hours. Coming to the solution, this is the table that I am going to draw for 1 hour 30, for 2 hours 60, for 3 hours 90, for 4 hours 120 kilometers that you will travel. So from this I took just unitary method. For 1 hour 30, for 2 hours 2 into 30 60, for 3 hours 3 into 30 90 kilometers. So this table once I make, then it gives me a graph appropriately choosing time on x-axis in hours, distance traveled in kilometers on y-axis. So for 1 hour he traveled 30 kilometers, for 2 hours he would travel 60 kilometers, for 3 hours he will travel 90 kilometers. That graph, I mean after plotting the points, after joining them, I got a linear graph here. From this I can say that 1 unit on horizontal axis is 1 unit in the sense here you could see 1 2 3 4. That means each unit is 15 minutes. On vertical axis 1 unit is 2 units 10 kilometers, 1 unit will be 5 kilometers. So this is how I have mentioned marking the time on horizontal axis, marking distance on vertical axis, plotting the points and joining them. Now corresponding to 75 kilometers, from 75 kilometers if I plot a line parallel to horizontal axis intersecting at graph a point P, from there if I drop a perpendicular to horizontal axis, it exactly intersects at 2.5 hours. That means he rides in 2.5 hours 75 kilometers. Okay. Further, I will answer second question. In 3.5 hours, he will ride, because 3.5 hours on time axis I took 3.5 hours, took a line parallel to vertical axis or perpendicular to horizontal axis intersecting graph at Q. That Q gives me 3.5 hours comma. After that, taking a line dropping from that Q perpendicular to the vertical axis, it exactly intersects at 105. So he rides in 3.5 hours 105 kilometers. This is how I will use the graph. Okay. So with this I'll go ahead with solving exercise of 15.3. In exercise 15.3, main question 1 consists 3 sub questions, children. One is A, another is B, another is C. In sub question A, cost of apples are given, where cost of apple 1 is of 5 rupees, 2 of 10 rupees, 3 of 15 rupees, 4 of 20 and 5 of 25. I am asked to draw the graph for them. So following tables with the suitable scales on the axis, draw them. So here I am plotting a graph. First I took a graph sheet, plotted a horizontal axis, plotted a vertical axis, took the point of intersection of them which are perpendicular to each other at 0. Then I am deciding a scale. What is the scale for me? Here I have chosen on y axis 1 unit as 5. Why I am choosing y is because I am taking cost in rupees on y axis and number of apples on x axis. Now on x axis 1 unit I am considering 1. Here on y axis 1 unit equals to rupees 5. Now with this scale, I took 5, 10, 15, 20, 25, 30, 35. Now on x-axis 1, 2, 3, 4, 5, and then plotting a graph. 1 is a 5, 2 is a 10, 3 is a 15, 4 is of rupees 20, 5 is of rupees 25, and if I join them, it gives me a linear graph. This is how we draw. Children, with this experience, I am giving you to work on sub-question B, sub-question C. You can solve them. Okay. So question B is homework for you. Question C is once again you need to work on that, practice them. Then I'll go for the main question 2. In main question 2, we are again to draw the graphing. They provided a table and they are asking us to plot the graph, and they are asking after plotting whether that graph is a linear graph or not. So first, in the main question 2, sub question 1, sides of a square in centimeters given for 2 centimeters, perimeter in centimeter is given as another quantity. So for 2, 4 2 is 8, for 3, 4 3 is 12, for 3 and a half, 4 3 and a half is 14, for 5 centimeters of side, 20 centimeter will be the perimeter, for 6 centimeter side, 24 centimeter will be the perimeter. Now to plot this, I am taking a graph, drawing a x-axis, drawing y-axis, and I am taking the point of intersection of them as origin O. Now children, on vertical axis, I am taking one unit as 5 centimeters, and here on x-axis I am considering one unit as 0.5 centimeters. Why? Because I am taking side of square in centimeters on x-axis and perimeter in centimeters I am taking on y-axis. Now after plotting the graph, we will have for 2 centimeters 8, here is the point, for 3 centimeter 12 comes here, for 4 centimeter, for 4 near, for 3 and a half we have, for 3 and a half 14 here. So like them I will be plotting. So for 5 centimeter we have got 20, so for 6 centimeter 24. Is it a linear graph? That is your question. So it is unbroken. You could see for it's, I could answer that. Okay. Now this is how we need to plot the graph, and I am giving sub question 2 in this main question 2 as a homework. This is the last question, and with this I will wind up this session, this chapter also. Revision of it got over. Next class will deal with another chapter revision. So till then, take care of yourself. Jai Hind. Thank you.